Every Azure VM you deploy lives inside a virtual network. Every subnet sits inside that VNet. And when you have two VMs in two separate VNets, by default, they cannot talk to each other at all. In this video, we are building everything live in the portal, more lab than slides. I will draw the architecture on screen first so you understand exactly what we are building. Then we go straight to Azure and build it step by step. We are covering virtual networks, subnets, VNet peering, and global VNet peering across regions, all demonstrated live. This is AZ-104 Domain 4 Networking. I'm Jay from Jay CloudSec. Let's build. Let me start by drawing the first virtual network. I am going to draw it as a house with a fence around it. This is VNet 01 with IP address 10.1.0.0/16. Think of it as a private building, a house with a fence. Everything inside can talk to each other. Nothing outside can get in unless you say so. Inside the house, we have a room. This is the subnet. Subnet 01 at 10.1.0.0/24. The fence is the boundary of the VNet. Azure puts this boundary around it automatically. It is always there. You cannot remove it. VM1 lives in this room. Azure gives it a private IP address 10.1.0.4. This IP only exists inside the fence. Nobody on the internet can see it. It is completely private. Now we have VNet 02 with address space 10.2.0.0/16. The two VNets must never have overlapping IP ranges. Azure cannot connect them when you add peering. Right now, these two houses have no connection. VM1 tries to reach VM2, but the fence stops it. There's no gate, no path. The traffic goes nowhere, it just dies. We will prove this in Azure portal. VNet peering is a gate. We are not knocking down either fence or building a road through the neighborhood. We are simply adding one gate between the two fences. Now, the two families can walk straight to each other privately without going onto the public street. Now, VM1 can ping VM2. The traffic goes through the gate through Microsoft's private backbone network, never touching the public internet. That is VNet peering. Now, let's understand what non-transitive means. Three houses in a row. House A has a gate to house B, and house B has a gate to house C. But house A cannot walk through house B to reach house C. Each gate is private and only works for the two houses it connects. If house A needs to reach house C, they need their own gate directly between house A and house C. This is what non-transitive means. If you need house A to talk to house C, create a direct peering between them. That is the only way both the house can communicate. Now let's go to Azure portal and see how it all works. I have built this before recording. Go to Azure Virtual Network and open VNet-01. As drawn on the diagram, VNet-01 IP address is 10.1.0.0/16. Then go to the subnet and IP address of subnet-01 is 10.1.0.0/24. Virtual machine VM-1 is already deployed inside subnet 01 with private IP address 10.1.0.4 and no public IP address. Bastion is deployed so we can connect to it securely. Watch my previous video on how to create and deploy Bastion. Now let's create VNet-02. Go to Virtual Network and click Create. Select your subscription and then resource group name, rg-lab-cus. Give network name VNET-02. Select region Central US. Click Next and leave all the security setting as default and click Next again. Change the starting address to 10.2.0,0 and leave size as /16. Click on the edit pencil and change the subnet name from default to subnet-02. Verify starting address is 10.2.0.0 and size is /24 and click Save. Click Review and Create. Once Azure validates the information, click on Create. It will take few minutes to deploy Virtual Network VNet-02. Next, we will deploy Virtual Machine. Now let's deploy Virtual Machine. Go to Virtual Machine and click Create Virtual Machine. Select your subscription and resource group as rg-lab-cus. Type Virtual Machine as VM-02. Image as Windows Server 2025. VM size as standard B2S. Username as Azure Admin. Create a strong password and remember it as you will need it later to log into the VM. Public inbound ports as none. Select license and click Next. Leave all the disk settings as default and click Next. For networking, select Virtual Network as VNet-02 and Subnet as Subnet-02. Public IP as none. Leave all the settings as default. Click Review and Create. Once Azure validated the configuration, click on Create. It will take few minutes to create VM. Next, we will log into both the VM, perform ping test, and create VNet peering. Let's go to the portal and see how it works. For VM-01 IP addresses 10.1.0.4 and for VM-02 IP addresses 10.2.0.4. I have already logged into both the VM using Bastion. Check my previous video on how to deploy virtual machine and configure Bastion. From VM1, open terminal and type ping 10.2.0.4, which is the IP address of VM2. Request timed out. Now let's go to VM2. Open terminal and type ping 10.1.0.4, which is the IP address of VM1. Request timed out. VM1 is in VNet-01. VM2 is in VNet-02. No peering exists, no route between them. This is the completely isolated default state of every VNet in Azure. Now let's create VNet peering from VNet-01. Go to your virtual network and open VNet-01. On the left side menu, click on Peering. Click on Add, Peering. Name for this VNet, VNet-02-2-VNet-01. Peering type, select Virtual Network. Select your subscription. For Remote Virtual Network, select VNet-02. Peering link name for Remote VNet, VNet 01 to VNet 02. Traffic settings. Leave all defaults. Click Add. It will take few minutes to complete the task and create peering between both the VNets. You only need to perform this step on VNet 01. Azure will create the peering in both the directions. Let's verify peering on both the sides. Go to VNet 01 again, then peering. You will see a new connection with status as green and connected. Now let's go to VNet 02, then peering. You will see a new connection with status as green and connected. Azure created peering in both the directions in one operation. Both must show connected. If either shows initiated or disconnected, check address spaces are not overlapping, and both VNets are in the same subscription. Now let's go back to VM1 using Bastion. Open your terminal and ping IP address of VM 210.2.0.4. Again, it's timeout even if we have allowed traffic to follow between both the VNets. In Windows Firewall blocked the ICMP traffic which is required for ping test. So go to Control Panel, then Windows Firewall. Go to Windows Firewall on and off configuration and disable the firewall traffic. Now if you ping the IP address again from VM1, it will be successful. If you try from VM2, it will be successful. VM1 and VM2 are now talking directly using private IP addresses over Microsoft's backbone. No public internet involved at all. Both directions confirmed. Peering works symmetrically. Now let me show you Network Watcher, where you can see how these resources are connected with each other. Search Network Watcher on top and go to the Network Watcher. On left side menu, go to the topology. Zoom in if needed, and then select plus sign on Central US region. Azure draws your live network automatically. This is the real version of what we drew on whiteboard before. We just did regional VNet peering, that two VNets in the same Azure region. It's called regional VNet peering. Now global VNet peering. Two VNets connected cross completely between two different Azure regions. VNet 01 in Central US and VNet 03 in West Europe peered directly over Microsoft's global backbone network. Everything works the same: private traffic, private IP addresses, no public internet. The only differences are there is a small bandwidth charge for data crossing regions, unlike regional peering, which has no extra cost. And the latency is slightly higher because traffic is crossing continents, typically 50 to 100 milliseconds between US and Europe. For the AZ-104 exam, know that global VNet peering exists, know the cost difference versus regional, and know it uses the same non-transitive routes. Anything you can do with regional peering, you can do globally. AZ-104, global peering equals cross-region. Same non-transitive rule applies. Bandwidth charge applies across regions. Regional peering is free. Both users Microsoft Global Backbone, supported across all Azure regions. Global VNet peering works exactly the same as region peering. Same steps, same portal, same connected status. The only difference is the two VNets are in different Azure regions. If you want to follow along and deploy this yourself, here are the exact steps. That is all that is needed for global VNet peering. Same private communication, same private IPs, just across different Azure regions. Exam tip: global peering equals same configuration as regional. OTL auto detects cross region and labels it global. Non-transitive rule unchanged. Small data transfer charge applies. Both regional and global covered on AZ-104. Let's recap everything we built today. Virtual networks, private isolated networks in Azure. Address space in CIDR notation. /16 for the VNet, /24 for subnets. VMS get private IPs automatically. No public IP needed when using Bastion. VNet peering, direct private connection over Microsoft's backbone. NOT transitive. Both directions auto-created in one step. Address spaces must not overlap. Both must show connected status. Global VNet peering, exactly the same as regional, but across different Azure regions. Azure detects it automatically. Small bandwidth charge applies. Same non-transitive rules. In the next video, we will cover network security groups, NSG, NIC level NSGs, and application security groups, ASG. How to control exactly what traffic is allowed in and out of your subnets and VMs. If you are building Azure networking for your organization and need help, the link in the description connects you with me. And that is Azure Virtual Networks, VNet creation, subnets, regional VNet peering, and global VNet peering, all built live in the portal. Hit subscribe for a new Azure lab every week. I'm Jay from Jay CloudSec. See you in the next one.